Hi, everyone. Can you hear me well? Yeah, that's how we usually start the meetings. Can you see my screen? Yeah, they forgot to mention one benefit about Grid Dynamics. They allow us to come to the office on Saturdays and work here. So that's a good thing. Yeah. Okay. So hi, everyone. And yeah, exactly. So like Denise mentioned, we have a trend about the AI-driven testing. And yeah, I'm not going to talk about this today. Instead, we'll talk about the anatomy of the testing and how yeah, I'm a little bit nervous, sorry. How web application testing, how we can make a difference when we're approaching the web application testing. Okay, yeah. So let me introduce myself. My name is Tasha. I'm a quality assurance engineer with over 10 years of experience. For past three and a half years, I'm working for Grid Dynamics company. And yeah, throughout my professional journey, I've actively participated in different phases of the product development and delivery. This involves initial project setup and overview, consulting services, and performing quality assurance efforts for both front-end and back-end parts of the application. My primary focus lately has been on the project within the e-commerce domain and some fintech early on. This presentation today is based on my experience setting up the test automation strategy for e-commerce project, but the concepts can be applicable for the other domains as well. So yeah, today we'll highlight the key challenges that modern web application pose to us. We'll explore some fundamental concepts and principles that underlie an effective testing strategy. We'll discuss workflows and testing approaches within our delivery and deployment pipelines. And we'll take a peek at some design principles that shape our testing approach. We'll also review some toolkit that can enhance our test automation strategy. And last but not least, we'll look into the concept of mocking and highlight its role in creating simulated development environments. Yeah, but first things first, there is no need to improve our testing strategy without a growing complexity of application of our system. And modern web applications offers a lot of flexibility when it comes to solving different business needs, but they also bring some complexity when it comes to testing. Like, for example, we have all these multiple integrations and multiple integrations involving different data flow that requires seamless data flow, sorry about that. And they have different data formats and requirements. And this complicates testing communication points between the systems. All these services, they might evolve independently, leading to some compatibility issues. And changes in one service might impact how others communicate with it. As the system grows and more components are added to the system, scalability and performance become crucial. Load testing and stress testing are necessary to make sure that our application can handle increased load and scale well. Testing complexity also increase with content and UI variability. And I'm not only talking about some layout shift on the pages, but also all these content management systems, personalized contents, A/B testing. This requires tester to account for all these different range of scenarios and making sure consistent functionality across the system's hardware. We should always consider the following best practices to overcome the complexities. First and most important, we need to develop a comprehensive testing strategy that involves and covers different testing layers, such as unit testing, integration testing, end-to-end testing. For this, from our end, we are adopting a so-called testing house model. It aligns effectively with modern web application. We'll cover this in a bit. Of course, we want automated testing integration into our CI pipelines and delivery pipelines. That will help us to gather all build feedbacks as soon as possible. We want to establish clear communication and collaboration channels between testing team, development, and business. We believe that QA implication on all stages of the development and delivery process is very important for the overall product success. Well, in addition, we also believe that following a single technology stack within a deliverable unit serves to bridge the gap between testing efforts and development efforts. It also simplifies a bit the integration to the CI pipelines. You probably will not make a UI developer run your test if they're written on Java, because they know JavaScript, TypeScript. So that's why it's important. Yeah, and let's start with the testing model. We use the well-known pyramid, and we use it as a guidelines for structuring and prioritizing our tests, and we adapted it to our testing needs. It aligns effectively with all the modern web application architecture, such as composable, microservices, or headless. Essentially, with the house model, we put more emphasis on the integration part. One of the goals here is to also make sure that each level is well defined, and all the roles and responsibilities are clearly allocated between the team members. It is all to maintain the balanced and effective strategy. Yeah, and as you can see on the bottom, basically nothing changed. We have this wide level of unit tests, and it's usually the development team who covers them, but the QA implication here, and I just want to stress this because as a QA, we don't write the unit test, but we want to be involved in this part as well. And our main goal and responsibility here will probably be to do the review and understand the coverage so we don't duplicate the testing later in the testing process. Integration level is a bit wider when we compare it to the pyramid, and it actually consists of two deliverable components, the UI and the backend one. And on top, we have end-to-end tests that are followed by exploratory and acceptance. And I think it's important to note here that in the context of continuous delivery and trunk-based development, at this point, the acceptance will be acceptance for a release candidate, not UAT or business. Of course, size and shape of the pyramid may vary from time to time. This can depend on various factors that not always under our control, such as, I don't know, budgets, capacity, or specific business needs. But in the agile world, it's important to be flexible with the processes and tools. However, what we believe that should never change is that we want to QA to start assessing application as early as possible and to maximize automation through the delivery and continuous integration pipelines. And let's take a look on the CI pipelines. On the backend deliverable build phase, our aim to ensure the access to all the integrated components. We can use industry standard APIs and tools to confirm that all the integration points, starting from the core services to all the backend for front-end components, are functioning as expected. For any application development dependencies, mocking and stubbing may help to establish some stable and simulated environments. It can significantly accelerate your development by reducing dependencies and isolate our system from some flaky third party, and even to simulate APIs that are still in development. We don't have to wait for the other team to finish with the API. We can use schema and simulate it. When it comes to the front end, again, we can use mocking tools to create a simulated environment. But this time we want to simulate the whole backend services. This allows us to easily develop and execute UI component tests on the front-end parts. This stage serves as an ideal point for validating components in different states and under different conditions, do some edge case testing or negative scenarios, or even to simulate some error handling. But that's not it. We can also perform automated visual comparison testing on all these UI components. This approach offers an effective way to ensure pixel-perfect responsible design on early stages. To address some of the non-functional aspects, we integrate performance tools. We want to ensure that the pages are well optimized. We want to track trends and pinpoint build or commits that have impacted performance negatively. These tools can also help us to expose some code changes that might have been improved, and that is to make sure that we can improve the overall code quality of the application. Yeah, and last but not least, we have accessibility. This is a practice that promotes web application inclusiveness. Don't worry, we'll cover all the stages in more details soon. On the previous front-end and back-end build pipelines, all the lower level checks has been done to confirm the build readiness. And now it's time to take these artifacts and deploy them to a testing environment and do some system integration testing. At this point, our primary goal is to perform acceptance and exploratory testing to evaluate the entire system and assess from end user point of view. And here we don't do any mocking. We want to rely on the real integration and frequently update our testing environments to match production setup. We can also add some performance part to the pipeline to ensure that application services can handle expected load and perform well under certain conditions. And all of these activities are to confirm the release readiness. Yeah, well, let me go back. So this was the landscape, overall testing landscape, how we see in general. But today we'll mostly focus on the front-end testing and the key factors that can enhance your UI testing approach and strategy. And yeah, let's start by briefly covering some UI design principles. Brett Frost has this amazing book called Atomic Design. Some of you may have heard about it. It contains all the details about what it goes into creating and maintaining the robust design systems. It introduces a methodology composed of five distinct phases that help to create design systems in a more deliberate manner with clear hierarchy. So the five components are atoms. These are the foundational building blocks. These are the basic HTML elements like labels, inputs, or buttons. Then we have molecules. It took me quite some time to pronounce word molecule correctly. For some reason, it's a hard word, but yeah, sorry, off topic. These are molecules are groups of atoms that form together a unit. Basically, you can have your input, label, and button built into a search form, which is essentially a molecule. Then we have organisms. These are relatively more complex UI elements. And for example, you can have your search form molecule as a part of the header organism. Then we have the templates. These are the layout page level components that that shows us how content would look like. And after all, we have pages. These are specific instances of a template that shows how the UI will look like with the real content. Atomic design helps us to organize design elements systematically, making them more accessible, and they can be used in both development and design. And one of the biggest advantages here that Atomic Design provides is the ability to quickly shift from abstract to concrete. And what I mean by that is that we can basically simultaneously see our interfaces broken down into the atomic elements, even the smallest one like button inputs, and see how they are combined together into a final experience. So why does it matter for testing? Well, beyond streamlining design and development, these atomic design principles play a crucial role when it comes to forming a UI testing flow. They offer tools and templates that makes testing in different browsers and devices easier. They keep performance steady, and they allow us to meet the accessibility standards quicker. This not only speeds up the development process, but also ensures the team collaboration more effectively. Well, with this atomic design foundation in place, let's explore how the design systems fit in our UI testing flows and the tooling. First of all, when we approach the UI test, it is important to understand that it's not always about Selenium end-to-end tests. Effective UI testing flows involves different tools that focus on different aspects of the UI. And yeah, here we can see a sample flow. You don't have to strictly follow that, but that's just a demonstration how it could look like. On top, we have the storybook. Have you guys heard about storybook? Can anyone raise your hands if you worked with it or seen it? Storybook, yes. Yeah, okay, I see a couple of hands, thank you. It's essentially a front-end tool that's used to build the UI components in isolation. Its primary focus to decouple UI components from business logic and application context. That's why the whole lower level UI testing flow can revolve around it. We can integrate a storybook interaction plugin to make our stories live, and we can run some functional interaction tests with it. We can integrate chromatic or Percy for visual regression flow and verify composition. For accessibility, there is a storybook accessibility plugin. For performance, it's not exactly storybook, but we can use Lighthouse for that. And of course, in the end, we have the end-to-end automation testing of the user flows. We should invest more into the lower level component UI testing simply because there is so much involved right now. Modern interfaces have countless of variations. All the components and pages can be viewed in all different states, in different browsers, in different devices, and even different viewports on those devices or browsers. And yeah, you can see this spider web over here. It can be sometimes very important to gather feedback about our application from quite some of these combinations. And simply running end-to-end tests on these combinations can take a considerable amount of time. I think you probably faced this before. With component testing, on the other hand, we don't have to always spin up the whole application and to go through the user flow just to see how a specific component renders on the page. Like, for example, if you want to see a reward or promotion component on the cart page, with the end-to-end flow, you'll have to open specific page, add a product to cart, then go to cart, and just to see that. With component testing, you can just pass in some properties and states and see this component installation. And yeah, the storybook is actually a tool that provides us with this isolated frame that can render all these components by passing in any inputs, any mocking data, or any states or events. So yeah, we have a story, and what's the story in the context of the storybook? All the UI frameworks are component driven. Remember, we talked about the atomic design principles, and that's why all the UIs are built bottom up, meaning that we are starting from the atomic components and progressively building into the web pages. Every piece of the UI is essentially a component, and a story captures a rendered state of this UI component. We can write multiple stories per component to describe all its applicable states and conditions. And collection of all the components in all these different states is a storybook. Yeah, on this example over here, we have an organism. These are two stories, organism in context of the atomic design. And these are two stories, basically. One of them covers the header organism with the user logged in, and the other one when the user is logged out. And there we have assertion to confirm that. The opposite. First one is logged out, second one is logged in. With the storybook, we can take a step further. Here's a demonstration of functional interaction test. We can make our stories live by interacting with the elements and asserting the results. And to achieve that, we simply need to install the interaction plugin. Okay, there it is. Under the hood, it's powered by the testing library and Jest. So you have this developer friendly syntax, and you can interact with the DOM elements pretty easily. Yeah, in this example over here, again, we have, well, this time, we have the login form organism, and we are typing in user email and password and submitting the form and asserting the result. We can find any necessary selectors by using test ID and action them using the standard API like click or type or hover, for example. Well, next is the visual flow. Storybook in combination with visual testing tools such as Percy or Chromatic allow us to accomplish a few important things. And here, the most important one is ability to run automated visual tests to capture snapshots of every story and compare them build to golden baseline to identify any changes. We can also publish these components and share with the team for review. You can assign a teammate to give feedback on your work in progress items or to give a comment on styling, behavior, and interaction. This makes change requests more clear and actionable. And the great thing about the fact that we are using Storybook in combination with these tools is that we don't really have to write any new tests, new visual tests, because we already have all our components in all different states that it can support. So we basically covered the test part and we just need to run the comparison. I mentioned Chromatic and Percy. These are paid solutions, but they offer, I believe, 5,000 snapshots per month for free. It usually is enough to cover what you need to do. But yeah, if you need to do more comparison, you'll have to pay or think about using some free solutions with Playwright, for example. Okay, next is accessibility. It is actually an often overlooked part of the UI testing flow, but it can greatly contribute to the end user experience. Because accessibility is a practice of making websites inclusive to everyone. And why don't we just make use of it and grow our audience, right? Some countries legally require your website to be accessible to everyone. So this accessibility practice becomes mandatory. And Storybook provides accessibility plugin, which is powered by Axe Core. Some of you might have heard about it. It automatically captures up to 65% of the all accessibility issues, and it does it automatically. So it comes for free. It does it automatically. Why not integrate it? And again, we have all the stories on all the states available for us. So how it works, in combination with Storybook, accessibility tool will run the analysis on and audit for your components against a standard set by the VCIG and other industry accepted best practices. Well, here on the screen, we are back again to our header organism. And here we can see that we did the audit and we found one violation, which is color contrast. So yeah, we can raise it right away. It's easy to fix and it's actually a critical one, or well, serious. Okay, still serious is bad. Well, accessibility, excuse me. Accessibility is actually a big topic and deserves probably its own presentation. But the bare minimum we could do is to run accessibility audit automatically to capture all these issues and raise them right away. Okay, for the front-end non-functional testing, there is one tool to rule them all, and it's the Lighthouse. Hope you've seen Lord of the Rings, otherwise this metaphor doesn't make any sense. And the Lighthouse is a is an open source tool that automatically analyzes the web page and provides valuable information for overall improvement. It performs audit for performance, accessibility, SEO, and other best practices. You might have used Lighthouse with, well, from your dev tool, but there is more to that. There is Lighthouse CI, which is a set of tools that makes continuous integration by running the Lighthouse audit as easy as possible. Under the hood, it uses exactly the same Lighthouse library as in the DevTools, but we don't have to run it manually and rely on someone to run this manually on regular basis. Conceptually, this will look the following way. You set up your CI to build and start the application. Then we collect results by running the Lighthouse audit. We assert applicable metrics that we need. We don't have to always do all four, but why not? And after all, we upload the results to our CI provider. And doing that, we can have Lighthouse report available alongside every PR, not like running this once a month. But that's also not it. Lighthouse CI provides a server that saves historical Lighthouse data. It displays trends in a dashboard and offers an in-depth UI build, UI comparison tool that and hide the issues and compare your different builds. These trends that we can gather, we can expose over time system degradation, or the opposite. It can actually show you that specific change improve the performance. And finally, we got end-to-end. With end-to-end testing, we evaluate functionality from an end user perspective. And our focus here will be the customer centricity. We should put our customer first and ensure that the software meets customer and user expectation. We want to focus on the customer flow, and our goal here is to improve user experience. We want to make sure that software delivers seamless flow. We should focus on simulating the real-world use cases. And will make it more effective to uncover issues that might have been missed on the lower levels. You might have heard the joke about the QA who walks into a bar and orders a beer, 2 beers, 0 beers, -1 beer, and everything is perfectly fine. And then first real customer walks into a bar and asks to use a bathroom, and bar explodes. It's funny, but it's also a demonstration of a tunnel vision created by not properly applying a testing model. We focus on all the number of beers scenarios on broad lower level testing. And because beer is just a component in a bar application, we should focus on the end user behavior on primarily on top of with the end-to-end testing. And one more thing about this topic, it's okay to have multiple actions and assertions within your end-to-end test scenarios, because here we want to test the whole application flow. When it comes to end-to-end, having long tests is not always such a bad thing. Okay, so previously we talked about lower level UI testing flows. We built it from bottom up. But managing component and integration testing could become complex because of all different dependencies that our system might have. And remember, on this lower level, we want to test our system in isolation. And here is another factor that is crucial to enable this lower level testing flow, and it's mocking. Stubbing and mocking concept is a key to achieve this stable development environment and simulate our various cases. What is a mock? It's essentially a custom object that allows us to have a predetermined behavior that simulates a real object. In a simple way to say it, we basically feed some sort of fake data to our system and to simulate these specific scenarios. we cut production API and we reconfigure our application to use mocking server instead. So basically, we can replace something we don't have control at all with an implementation that is fully under our control. So how it works? As we just mentioned, we reconfigure our application to use mock server. And now every time an API consumer makes a request, it goes directly to our mocking server. And mock servers usually rely on three concepts when it comes to simulating the API scenarios. First one is routing. They define matching criteria for the incoming request. And modern mocking servers, they are flexible enough that you can provide any HTTP request attribute to use it for matching, like path, URL, headers, body, anything. Then there are response variants. They define how our server will respond back. And mocking servers can provide different variants of the response based on the matching criteria. So it means we can simulate any response that we actually want, like starting from successfully fetching all the data that we need to a 404 response not found, content not found, and even server failures like 500 errors. And after all, we have collections that define all current routes and variants that our mocking server supports. So we can use mock servers and stop all necessary APIs to get data to match our scenarios. For the component integration testing, this is essentially what we need. A functional application with a preset behavior that is not burdened by any third-party integrations, dependencies, or, well, anything else. It will be much quicker to install, run the test against it and integrate it in our CI process. And what will we get? We can accelerate development by enabling testing without having to wait for an API availability. We can simulate all kinds of API responses, including error scenarios or edge cases to simulate our test to enable our testing. It can also improve the test reliability by eliminating some flakiness because of the network or third-party dependencies. But it's important to understand that mocking is not a silver bullet. It's not a response for anything that's happening throughout the software testing. We need to use mocking wisely because some over mocking can actually hide the real issues. So for end-to-end testing, we should strongly avoid using mocking and rely on the real integration to do proper full system testing. Let's quickly summarize. At the integration component level testing levels, we test all states and conditions. We cover various edge cases. We can validate error handling to some extent. These tests offer an effective way to minimize the cost, expand the coverage, and pinpoint some real issues on the early stages of the development, on the lower levels of testing pyramid. Through end-to-end testing, we validate the entire system. We cover a variety of the real-world customer scenarios. This process ensures consistent flow through all the components that our system has and creates a comprehensive user journey mapping as well. And of course, with performance, it's also an important part, but we didn't have a chance to cover this, but yeah, I'll just talk about it. Continuous performance is crucial to confirm that our application can handle and can manage increased loads and scale as needed. Creation of workload simulations and collection of performance trend can greatly contribute and provide an confidence that user will have a seamless and performant experience. Yeah, so it took a bit longer than I expected.
Just fine.
That's it. I guess we have some time left for questions.
Thank you, Alex. Indeed, here we go with the Q&A session, guys. Feel free, I will give you the microphone. You don't have to stand up if you don't want to, just feel fine sitting on your couch. If you have questions, please relate to the topic. Relate to, maybe you have any other experience to share or any greater ideas to change some tools for us. Please feel free, yeah. Hi, my name is George.
Thank you. Kirill. Maybe a little bit a silly question. I'm sorry about my voice. You said about the documentation, how good the documentation you have and how much time you spend to write them.
Are you talking about any specific technology that I talked about or in general?
No, in general. You know, when you have a really big amount of the deadlines, you don't have time for documentation. So I ask about this just to understand the workflow from the other part.
Okay.
If it's not a secret, of course.
No.
No secrets.
Our trend is to try to always use open source technologies without creating reliance on a specific platform and not to pay extra money. Budget is another constraint. And we are trying to look for solutions that are open source and have been on the market and proved to be acceptable for different kind of problems. For example, I talked about the mock servers. I didn't provide any examples of the tools that we can use, but there is a great tool, VarMock. It's a Java-based tool. You can run it in Docker container. You can run it on your machine or deploy it anywhere. And it's pretty flexible when it comes to creating some sort of simulations. It has an API. You can provide it as a code. And it has all great documentation and community around it, as well as Storybook. Playwright is kind of new. I mean, it's been there for a few years, but it continuously growing, and it has a lot of people in the internet who can help you with your questions. And even ChatGPT responds about the Playwright. Okay, I probably misunderstood the question.
It's good. I mean, for example, if a person like me from a site will see the documentation, sorry, will I, for example, understand the flows that you use?
If you have some background in
Yes,
tech and testing, okay. So for example, with the Storybook, it's a little bit more developer tool, but if you have some level of exposure to React components or Angular, it is just fine. With how you set up the testing, it's also pretty easy to do if you have experience with Selenium or Playwright or Cypress or any other tool, because conceptually they are the same. You find an element, you action this element, and you validate the result. That's it. I mean, that's how everything in testing works from my notes.
Thanks.
And yeah, documentation is great with good examples.
Thank you. But by the way, guys, yeah, okay, I seen you. Yeah, we don't have silly questions. Yeah, just ask. Don't be shy about that. Sometimes we have even much stupider questions. Don't worry.
Hi, my name is Sergey. Sorry, I will speak in Russian because I have a lot of. Yeah, thank you. Да, в первую очередь хочу поблагодарить за презентацию, потому что она действительно была на очень высоком уровне и очень понятной, и практика, которая там сейчас, ну, наверное, соответствует всем, ну, нынешнему 2025 году. Это прям идеальный сценарий был. Да, но ясное дело, что как в каждом идеальном сценарии здесь очень много всего зависит от команды, которая у вас есть. То есть у вас действительно должны быть хорошие разработчики, у вас действительно должны быть хорошие дизайнеры. Опять же, по поводу, ну, сторибука. Мы применяли сторибук у нас в компании тоже, но, как говорится, бывают иногда моменты, когда где-то что-то ломается, но абсолютно верно также, что он для React просто идеален. И то, как было сказано в начале, если у нас будет тестирование компонентов с точки зрения даже автоматизации, мы решаем огромное количество проблем с точки зрения пирамиды тестирования. То есть мы очень много сможем на уровне юнит-тестов, скажем, end-to-end юнит-тесты с точки зрения визуализации, ховеров, эффектов и всего остального. То есть действительно очень-очень крутая презентация.
Спасибо.
Спасибо. Спасибо большое за доверие and for your appreciation. Yeah, about the ideal teams, that's some, fairy tales. Don't worry about that. Thank you, Alexander. Any other questions, by the way? We still have some time. Yeah, Irina, thank you.
What's the interaction between manual QAs and automation QAs?
In the ideal world, okay, it probably will always depend on the project. So sometimes, not in the ideal world, you have your development team, your manual testers, your automation testers, your performance testers, all work independently without understanding the whole context about the application. And if it works like that, we have the manual team handle the test scenarios to automation team. But we had an internal speak from one of our colleagues who mentioned that automation engineer should have great exposure to what's going on in the project and creates his own how to say that, scenarios for automation, because not all manual scenarios can be automated and provide same level of efficiency, because sometimes you can catch some issues with your eyes, which automation tool will not. I mean, how it works under the hood, it will just look for an element on the page and click on it, for example. It doesn't care where it is, on top of the page or bottom of the page, like left or right. With your eyes, you can capture that. Visual tools will solve that. Yeah, back to your question, sorry. Yeah, usually they work as a team. I mean, we used to have full stack QA kind of thing where one person can do everything. It's some sort of a unicorn because it's hard to find people who can do everything. In development, it's the same. Full stack engineers are hard to find. But yeah, we want to work them as a team and cover testing from different angles. And but all of them should have the same exposure on what's going on with testing.
Thank you. You answered the question. I have another one. Do you use AI tools? Maybe AI plugins for automation?
I personally don't use AI tools, and I can answer why. As a service company, okay, so what? Sorry, with AI tools, some people say that we want to try to replace developers and testers. As a service team who provides development and testing services, we don't want to be replaced. That's maybe that's a silly answer, but that's true. And currently, I don't think AI can fully replace testing or either manual or automated. It can support us to some extent. It can help you to create some sort of test scenarios to cover requirement. You can then review them and understand whether it was full or not, or you can provide it more context. It can do this for you, sure. It can even create playwright or whatever test case for you. It can do that. But is it maintainable enough, or is it robust enough? Can we reuse it? Can we build a project object model with it? We can probably if we integrate Copilot with our VS Code. But yeah, I don't think we're there yet. And it's actually sometimes more expensive to use AI tools than usual person engineer.
I got it. Thank you.
Thank you, Irina. Thank you, Alexander. Thank you very much. It was really, really, really insightful and a lot. Okay, you have one more question? Okay, one more. This is going to be the last one for the Alexander, but if someone else has some more questions, don't hesitate in the breaks or after at the pizza time, Alexander Grishin, come to him and ask him whatever you want.
Yeah, I can.
Okay,
I can
thank
hear
you.
Debugging. Sure. So on lower level, we have the storybook. It don't have to be storybook. There is other tools for that, but going from example in the presentation, let's go with the storybook. It provides you with the UI, where you can see all these interaction tests, all this visual or well, just simply asserting. And it has the console where you can see what's going on and where it fails and provides you with exact, as how it's called, the exception, how it failed. With end-to-end, we have Playwright, for example. Again, Playwright, well, I worked with Selenium for a long time, but with Playwright, debugging tool is just amazing. You can actually see every step, every action, every assertion, what happened at that time with a snapshot of the screen. You can see all the console logs, what happened at that time. All the network requests, like literally everything. I mean, it helps debugging a lot. And then you can see if the error was due to, well, human factor, you missed some sort of locator, it's fine, it's easy to fix. But if you're clicking on the element on the page and it's visible and it's clickable, it's actionable, but nothing happens, then the problem is with UI. I mean, with how frontend was set up. There is a hydration issue. It's happening everywhere, for example, where you have this element on the page appeared earlier than you have the script to support it. So that's why you can sometimes see that you clicked on the button, but nothing happened. That's why that happens because Playwright or Cypress, they're pretty fast. I mean, once they have this event that button is there, it clicks on it. Human. Okay, we are in 2025. So those implicit, explicit waiters are not required with this Playwright or Cypress tools. Tescafe. I mean, I mostly work with the TypeScript and JavaScript tools. I used to work with Selenium, where you had to sleep or wait for something. Those new tools, they do it for you. I mean, if you click on the element, they will wait for it to be available for you. They will not try to click and fail right away. You can set up these timeouts for actions, assertions, or general page load times. Yeah, so highly recommend this.
Thank you. So the main idea is don't wait too much. Okay, thank you. Thank you, Alexandru. Let's give one more roll of applauses because that was great. My brain was heated up. Thank you.